Hello everyone, today I'm going to present our work, Safe Leaf Manipulation for Accurate Shape and Pose Estimation of Occluded Fruits. There is an increase in the fruit consumption as a global scale. However, to do tasks like fruit monitoring is very labor-intensive and tedious. Robots offer a promising way to automate such tedious procedure. In a glasshouse environment, the fruit surfaces are usually heavily occluded by the dense foliage. On the right-hand side, in a sweet pepper glasshouse environment, people have been using shape completion method to estimate the shape and the pose of the sweet pepper from partial observation. However, such approach struggles to achieve good accuracy when the sweet pepper instances are heavily occluded by the leaf foliage. For example, on the left-hand side, the yellow sweet pepper is heavily occluded by this leaf in the front. We show two state-of-the-art shape completion method where we can see that the predict triangle mesh showing the blue color is different from the red triangle mesh, representing the ground truth, shape, and the pose of the sweet pepper instances. Our idea was to use physical manipulation to move the leaf aside, which allows for direct observation of the hidden parts. Here, we can see that using simple heuristics are not sufficient for this problem. When the heuristic is very conservative, it may not achieve good visibility. If the heuristic is aggressive to achieve good visibility, it may easily damage the leaf. Our system proposes a way to generate the action that is simultaneously safe and achieve good visibility. We take RGBD image as input, where we first use sync-consistent shape completion method to get the complete triangle mesh for the branch part, the leaf part, and using a point cloud representing the leaf. We will instantiate a simulation model which can be used to predict the safety score and evaluate the visibility after the action execution. We will select the best action that is simultaneously safe and achieve good visibility in the end. In the next section, I will provide more details on the shape completion method and the perception-driven deformation model. First, on the shape completion method, the key insight was to using the free space and peduncle constraint to regularize the estimate shape and pose from partial observation. On the right, when there is no sync-consistency constraint, the estimate the shape of the sweet pepper has clear collision with the free space region computed using recasting from the point of the RGBD camera. We can also see that the pose of the estimation process is incorrect, which deviates from the branch direction. On the left-hand side, using our proposed approach, the estimate shape and the pose of the sweet pepper are much more accurate. The perception-driven deformation model using a point cloud of the leaf to instantiate the embedded deformation graph, which can simulate the leaf deformation. Low-energy action that gently pull the leaf aside will be more likely to be selected, which will be beneficial for the leaf safety in the execution part. On the right-hand side, we can see that the stretching action, which will likely tear the leaf apart in the real world, have a high energy score, which will be less likely to be selected during the action execution. We evaluate our system on 12 artificial leaf and 16 real leaf instances. We have variation in the leaf sizes, relative pose between sweet pepper and the leaf, and also the shape of the sweet pepper. We first validate that the good visibility significantly improves the shape estimation result. On the first row, we show the estimate shape from the partial observed point cloud. On the second row, we show the result without any occlusion where the leaf has been moved aside. We can see in such scenario, the estimate the shape and pose of the sweet pepper in the blue triangle mesh is much better aligned with the ground truth red triangle mesh. We can also see that our sync-consistent shape completion method achieves the best fruit shape and pose estimation compared to existing state-of-the-art method. We also validate that our system can plan actions that is safe and achieve good visibility for different instances. Here we show two representative examples where the robot gently pulls the leaf aside, and we can see that the final pose and shape estimation of the split pepper is much better aligned with the ground truth result. Here we provide quantitative results where we can see that our system systematically achieves good visibility and little damage both in artificial and real plant scenarios. Our system can also naturally scale to multi-fruit scenario, where in this case, given different split pepper instance, our planning system sequentially executing the action of different split pepper instance and achieve good shape and pose estimation of individual split pepper. In summary, we propose a system that can actively achieve good shape and pose estimation of fruit for monitoring tasks. Our two key contributions are the thin consistent shape completion and the leaf deformation model, which can be used to do planning that generate safe and effective action in the heavy occlusion scenario. Thank you for your attention.